Cool. Now I'm recording. Okay. Yeah, this doesn't help with Windows padding issues. I'll look at mine and see later if there's anything magical I had, but I can send out screenshots and stuff of what I have. So my main CPP file ended up including sorter.h because that was where your prototype for your functions are supposed to be. Other than that, nothing. I don't think anything else changed in here. From sorter.h, I think is where I get a function for sort vector. So if we go over to sorter.h, this is all it looks like. I think I could have commented that out as well. It's really just the prototype for that function.
Yeah, I had to put my include after using namespace standard to get to work.
Okay. Maybe it's different compiler versions or something like that. But I know that's the kind of stuff that was the things to figure out while you're changing the way the code is laid out. No, I got this to compile without the include in my header file.
Yeah, I did use a line of code. I think it was called pragma once, or something like that.
Yeah, I didn't go into that because the intention there is so if you have multiple modules including the same thing, it only gets included once when it's doing all the compiling and linking. For this simple example, it didn't need it, but that is a good practice. Now, did your compiler force you to have that?
Yeah, well, when I ran it without it, I think I needed that, and I think I also needed to include IOStream on each individual file.
Interesting.
And,
yeah, I mean, I'll double check mine, but yeah, mine compiled without the include here. Sorter.cpp, that's where I needed the vector include, the vector include.
So I was able to leave that out because I had it included
in the .h.
Yeah, I was too.
Okay.
I had just had .cpp actually.
Okay. Because when I went on my compile, or here, I'll show you my makefile. That's kind of the point of this. The first thing I did was I compiled that sorter.cpp. And so when it's compiling just sorter.cpp, there's no main.cpp to include the vector, right? Since it's kind of compiling in isolation.
Yeah.
So that's why I ended up needing, actually I didn't, does this include the .h file? No, it didn't include the .h file. So.
It shows like Visual Studio shows an error in sorter.cpp if I don't include vector, but when I use the makefile, it all works fine.
So if I comment it out here, yeah, that'll complain even if you had it in the header.
But just if you run the makefile, it should still work, I think, even if it's complaining.
There you go.
Yeah.
So there is no one answer. And those are the things you have to work through. All right, let's get to tonight's content. This is going to be our last lesson of content. I'm kind of sad about that, but we'll get through it. It'll be fun. We are going to talk about protected class members first. So we were talking about inheritance. This is where the protected method or the protected accessor modifier comes into play. So public members of classes can be referenced anywhere in an application. So if your class has a public variable or public method, any code that is referencing that file can access those members. Private variables and private functions can only be accessed by that class, by the class that defines them. And I'll show you examples of all this in a second. So private members can only be accessed by the function that defines them. They're not allowed to be accessed directly by any object or function outside of that class. So those are the two extremes of access to variables and functions. Kind of in the middle is what they call a protected member, a protected member. So it's a variable or a function. It's similar to private, which means outside of that class, it it can't always be referenced. The only time a protected member can be referenced outside of the class that defines it is if it's in another class that is inheriting from that base class. So if we have a base class, when we did road vehicle, if road vehicle had a protected member, the extending classes or the subclasses like car, truck, etc., can access the parent class's protected members. So this little bit of code shows how a protected member works. So this is first CPP. It's available. You can link to it. It'll download it. But there's a parent class, and in it, it only has a ID protected integer that is accessor modified to be protected. Then we have a child class, which inherits from parent with a couple of functions. One is display and one is set ID. So set ID and display are the public functions on the child class. In that child class's code, you'll see it's referencing ID protected, which is defined at the parent class as a protected member. That is okay and good. In the main function, which is outside of both of those classes, it can only reference those publicly declared interface things, the functions or variables. In this case, it's the two functions. So in the main code, we create a child object, obj1. We call the setID function, which is on the child class, and it's assigning the ID variable to the ID protected class member, which is a protected member of the parent class. And then there's a function display ID, which prints out ID protected is, then the value of ID protected. So this is a good use of a protected member. And this, I switch sides. It's a very subtle difference. Second.cpp. You'll see the one changes down here. I am outside of those classes in the main function, trying to reference object1.ID protected to assign the value 81 to it. Anyone want to guess? Is that going to work? No.
I don't think so.
No, that doesn't work. That doesn't work. Because the main function is not in the child class. The main function is code outside of the classes, and therefore it does not have access to protected members. So if you try to run this code, the compiler will tell you that. It will say ID protected is a protected member of parent, the line of code with the error, declared protected here. It's nice and telling you where it's declared. This could be very helpful if you have complicated classes with lots of class members, maybe even classes that have the same variable name in different classes, that kind of stuff. So it's telling you exactly where the declaration of that variable was. The main function is not part of those classes, so it's not in a hierarchical relationship with the base or the parent class. Anyone have any questions about that?
Nope, not me.
So on the second example, if this were declared public, then I could do this. If this were public, then I could access it. If it were declared private, the child class could not access it. But since it's protected, it's that middle ground where the child class can still access it, but any code outside of those classes cannot access it. Uncomfortable silence if anyone has questions.
Yep.
All right. The next part is calling the constructors of a superclass. So in that last example, we had the base or the parent class, or the parent and child. We had the parent class and the child class. There were no constructors in that case. But in this case, we have we're going to talk about how a child class can reference a parent class as constructors. This is used to set private variables on a superclass, primarily. Or this is how you set private variables on a superclass. So let's say we have a superclass, which is the parent class or the base class. It takes a parameter in its constructor called foo, an integer foo. And when it's constructed, all it does is it prints out superclass, foo parameter, value, end all. The subclass, which extends superclass, has a constructor that takes two variables, one foo, one bar. And there's this little syntax here that says when this constructor is called, first call my parent constructor that matches this signature. In this case, it's the single integer signature. After it calls that parent class constructor, its own constructor will execute. And in this case, it'll print out subclass foo bar parameter, foo comma bar, end all. So we create an instance of that subclass C, passing in 10 for foo, 20 for bar. First step is to call the parent constructor, then execute the code in its own constructor. So it'll print the superclass and then subclass. Yes, it will. So let's show that. Parent. All right, let's make sure y'all can see that. Y'all see that okay? So I'll compile that, execute it. Superclass came first, subclass came second. So if I kept a private variable here on the superclass for foo or something else, I could set it in this superclass constructor, or in the parent class's constructor. So everyone get the order of those operations. This syntax is a little weird. There's a term for it. I forget what it was. It was something about constructor listing or something like that. But you have, since C++ supports multiple inheritance, I think in Java, C#, those do not support multiple inheritance. So you have the concept of a parent or a super. You call the super function and pass in the parameters. Here you tell it what class constructor to call. All right, and the next topic. We are going to talk about building a console application, which is what you guys have been doing all semester. But I want to get into something that is more usable and interactive to do some real work. So a console application from Wikipedia is defined as a computer program designed to be used via a text-only computer interface, such as a text terminal, command line interface on some operating systems, or a text-based interface included in most graphical user interface operating systems, etc., etc. Some examples. Whoopsie, go back. Always do that. VI, Nano, G++, fdisk, curl, wget. These are pretty standard Linux-based command line applications that you would run from a terminal and not in a pretty window like Chrome. The idea here, or what we're going to go through in this code, I'm going to go through building a full application with you guys. We're going to build an interactive console application that validates different data types. We will validate whether the input that a user supplies is a string, a Boolean, or an integer. We'll have the concept of a top-level menu that will prompt the user for what data type we'll be validating, and then we'll ask the user for that data type. And so for a top-level prompt, we have some example here. Please select the data type by number below, print out 0, 1, 2, 3. If the user types in 0, we want to validate a string, which I guess is really any input that has characters in it. whether it's a Boolean looking for true false, whether it's a valid integer, and if they type 3, the intention is to exit the program. So once they type the user input, we'll prompt them, Boolean true false, and then after we'll output your input is or is not of the data type. So can everyone kind of visualize? Question, yes. Okay, I'll get to that question in a second. Everyone kind of getting a quick understanding of what this application should do? I'll take that as a yes. Yeah, so multiple inheritance is when a class can inherit from multiple parent classes. So all the examples we've shown so far have been inheriting from one parent class, but a class can inherit from multiples. And you would do that when you have, I would say, different functions being defined in the parent classes. A common pattern for that is like an interface. So if we wanted something that always had a toString function or always had a toXML function, like if you wanted to be able to print your class out to XML, you could inherit from a class that says, I have an interface function that will allow you to call toXML. That doesn't really have anything to do with the purpose of that object. In the case we had here, where we have a bad example because they're pointless, but a base or a parent and a child class, the purpose of those classes is defined as the parent or the child. Like our road vehicle, like it has to do with being a vehicle on the road. The truck has specific attributes to be a truck. But if we wanted to add behavior to it, typically, we could inherit from another class that had like a toXML function, where it's not really defining the structure of the class, but it's defining more what capabilities does this class have. That is a typical use of having multiple inheritance. Yep. All right, console application. So I'm going to break this up into a couple of different things. And it's all in, actually, sorry, it's all in one function, validator.cpp. And I'm going to work through it kind of a couple lines of code at a time. This could be broken up into multiple CPP and .h files, but for this, I'm just going to go through one actual CPP file. So at the top, I'm going to define some prototype functions that I know I'm going to use within my application. One I'm going to call print menu. One is integer, is bool, is string. You can see they all take a character pointer or a string pointer as the input. Here's a quick main function. I know I'm going to have a variable for my user input. That is going to be my menu input. I have a variable for my data type, whatever data type they want to.
Thank you.
You're welcome. No,
Oh, sorry.
I'm kidding. A variable to store whatever variable type we're going to validate, and then a third variable for the data input or whatever input we want validated. I have a Boolean for success, whether it validates or not. And here's the cool or the standard way of building this kind of console application. I have an infinite loop. It's going to run until I break out of it. So at the top of this loop, I'm going to print out my menu. So all I do is I print out my menu and it says, please enter a 0, 1, 2, or 3. I'm going to then get the user input. User entered whatever, just for debugging kind of purposes. If the user inputted the string 3, I'm going to break out of my infinite loop and finish my program. If the user entered a 0, I know they want to validate a string. If they enter 1, they want to validate a Boolean. If they enter 2, they want to validate an integer. So far, so good? So far, so good. After that, please input some data to see if it is a... Have we seen printf before? I forget.
Yes.
Okay, I like printf. This way I don't have to do weird string concatenation. It's doing what's called variable replacement or substitution content. Please input some data to see if it's a %s. %s is a placeholder, meaning I am going to take a parameter to this printf function and put it in place of that %f. This is a neat function within C++. You don't define, when the function is defined, the interface doesn't have a set number of variables. It has some special syntax, so it can take 0, 1, 2, infinite number of variables as parameters. So if I had multiple %s's or whatever, you can put a %d for integers. You can find it all online. You can pass in multiple parameters after the string to replace multiple placeholders. So please enter some data to see if it's a whatever the variable type is. Because printf for strings, it needs a character pointer, not a string object. So, or like a C string, like we talked about earlier. So the string variable has a function to get access to its character array, or its C string. So it'll print that out. Then I get another user input in my data input field using the getLine function again. Then I just do some quick logic. If the variable type equals integer, because I can compare strings like that, I call my isInteger function, again passing in the C string and setting the variable to success. Boolean is bool, string is string. I could have made this a switch statement. I could have done if else if because it would have been more efficient, but it's 3 if statements, so I'm not too worried about it. And then here, it cuts it off at the end. Your input, %s, the first string. This second string is the is or is not. And the third string is the variable type. So you can't, you can see this here. So the first one is the data input. So your input, data input, is or is not. I'll show you what this is in a second. And then the variable type at the end. So going back to kind of how I define this, your input is or is not a whatever the data type was they entered. So this is a cool little constructor here. It's called a ternary operator. So it's basically an if statement kind of combined into one thing. So the way you read this, you say if success. So success, again, we're evaluating to a Boolean. So this can be done with any equals equals or comparison or anything we've done so far. But in this case, it's already a Boolean. So if success, then the first value is returned. So the thing before the colon. And so if success, then my value is. If it's not success, then it is not. So if first value, else second value.
I was under the impression that you hated ternaries.
Yeah, I heard that too.
Did I say that? They can be really misused. And I'll tell you why. So I was doing a code review the other day, which I don't do often. And the line, I have a couple of friends who are also senior type software engineers like me, and whenever I see bad code, I always share it with them. It's kind of fun. And I saw a block of code that had literally 7 embedded ternary functions. So, like, this is as simple as it gets. If this value, else that value. Well, they had if, then another ternary here with another ternary embedded. It was literally 6 or 7 in a row. And at the end, it was like return null or something like that. It was just really, really bad. Oh, Aiden, is that going to be bad code? Does it say the first thing is ternary expressions?
No, there's just a lot of bad code.
Yeah.
If you ever want to just enjoy some bad code.
Nice. So I'm not going to quiz you guys on a ternary expression. If I do, it'll be a extra credit kind of thing. But I wanted to make this as simple as possible to get this this whole printf on one line, and so that was how I did it. So if the first value, else the second value. So that's just going to print out the status.
How that we use one is like if an if statement didn't deserve 3 lines of my code.
That's exactly right. If I had done an if statement, I would have had an if statement, a printf, else another printf, or another variable for success or whatever. So this worked out well. So if you understand the ternary, awesome. If you don't and you're interested, read up about it. It's a pretty cool little operator. It can be misused, and that's probably why I said I don't like it. Then my actual function implementations. So my print menu function literally prints out those things. The reason I put that in a function is now I can just call the function over and over again, and it kind of cleans up the code in my main function. Is integer, takes a character input, executes some funny code here. Whoops, I copied and pasted too much from the internet. I didn't need those. There's a neat function called strtol. I don't know what that means. But what it does is it looks at a string input and it ignores white space at the beginning, which is kind of cool. And then it starts processing the characters that are numbers until it finds something that is not a number. And it returns, and so you'll see it has 3 parameters. The first is the input, the string I want to see if it's an integer. The second is a character pointer. The third is the base of the number, so base 10 binary, base 2 hex, etc. And the return value is the integer that it finds up until a string that is not an integer. So I'll show you how that works. It's actually kind of fun. And if that pointer character, the second parameter, is a 0, that means it found the null termination of the string. So the end of the string was a 0, or the end of the string was a 0. If it's anything else, like if it's a 3 or if it's an A or a B or anything like that, this will evaluate to false, and is integer will return false. So it's kind of neat. Is bool, I do a quick string compare if it's true or false. Is string, I do a quick, is the length of that string greater than 0? That's kind of how I defined if it's a string or not. All right, so let's run that code because I think it's pretty fun code. So I'm going to compile my validator CPP, and I will execute it, and I can enter things here. I'll enter 3, and the program ended because I broke out of my infinite loop. Let's enter 0 for a string. User entered 0. Please input some data to see if it's a string. So I'll type in a string. Your input, blah, 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 is a string. If I enter, or if I try to do a string with no length, your input blank is not a string.
Would everything evaluate to being a string?
Yes, anything. I just checked string length. So if it's greater than 0, then it'll be a string. Boolean. Junk is not a Boolean. Boolean true is a Boolean. Boolean false is a Boolean. And I was case sensitive, which I maybe didn't have to be. But since I was case sensitive, capital false is not a Boolean. All right, let's do an integer. So if I type in an integer and press enter, is an integer. Oops. This is the part I think is neat. I can do a bunch of spaces. 5 is an integer. And I like that implementation as opposed to using ATOI, which is a string to integer thing for things like that. It just was kind of cool. What else is I got? Oh yeah, so ASDF is not an integer. Special characters eval as like those. So if I do an integer and special characters, it'll still say it's not an integer. So what I want to show you is, this is just for fun, that oops. That validator function for is an integer. I guess I don't really need those. I had these count lines to show you exactly what it's doing, which is kind of neat. So you'll see I'm going to say found number is li1, which is the return, which is the return value of the strtol function, and then I print out pend, or what the value of pend is. So it'll be a single character. Single character. It might be more than one character, and that's okay, because by dereferencing it here, I'm just comparing for one character. So anyway, let's compile that again. I will look at the integer, and here I will type in integer, and you'll see found number is what I typed in. Pend, there's nothing in there, so that's good. But if I do an integer with an a and some more integer after it, it returned the integer at the beginning, but pend was another string with the rest of the data. Everything that was not and beyond that was not an integer. And because that was not just a null point or a null terminator, we know that it's not an integer. So that's what that function does. It's kind of neat. And so if I do that with special characters again, I can start with an integer, put in some junk. Same thing, it finds the integer at the beginning, but then finds the rest of the junk. And they're just characters. So that code's all linkable. You can run it if you're so inclined and step through how it works. The important things here are how I'm printing out a menu, calling those functions based on user input, and have a infinite loop at the beginning. Any questions about that so far?
Guess not.
Guess not. All right. This is going to be fun. And I was hoping y'all would delay this because this is not good. No. So I've thought about our exam a lot. And I've thought about our homework a lot. And at this point in time, we have today, we have next week, and then we have the exam. I am not interested in sitting with you guys for 2.5 hours for an exam, making you code from memory in an exam, just because I want to be nicer than usual. So what I want to do is give you homework tonight that's actually part of your exam. You're going to have 2 weeks to do this. It's going to be a good bit of code, but you have 2 weeks to do it. This is going to cover, is the code pass fail? No, it'll be a grade or grade like usual. So if it's a 80% qualified, you'll get 80% on this 30%. I'm trying to think of coming up with an official rubric kind of thing, but I don't usually do that, so that's a challenge for my brain. But I'm working on that. So I don't have that for you today, but that'll be the gist of it. Like It is not a 0 or 100. It'll be a scale like your homeworks. This homework does, or this, I keep saying homework, this coding will require a lot of what we have talked about throughout the class. And so because of that, you know, we're going to do open book, open notes, all that kind of stuff. Yes, we're making a banking thing. Good job. Information. I have another slide with all the homework information. When you submit it, this is how I want you to submit it. In your repo on GitHub, under an exam folder, I want these files: account CPP and an account.h, checking, saving, credit card, main.cpp, and a make file. Okay, I'll go to the actual homework in a second. This will be due Thursday, May 6th at 7 p.m., which is our exam time. So open book, open notes. Don't look on the internet for code to solve this problem. Don't collaborate with other students. I put in this next note because I care. I have sent students to the Honor Council because of collaboration on an exam question. At first I felt bad about it, but then I realized I wasn't the one doing anything wrong. So please don't make me do that again. The exam will be, oh wait, I'm totally messing this up. Hold on. When did I say this is due? This exam code is due by Wednesday, May 5th. I'll say it again. This code is due Wednesday, May 5th. And then for the exam, including that code, don't take code off the internet. Don't collaborate with other students. The exam, I will have a 2-hour time period. I don't think it will take you 2 hours, but we'll see. I will budget that amount of time. If you cannot be there, tell me ahead of time, please, and we will work something out. The more notice you give me, the happier I'll be. Next week, we will do exam review, but I'm not going to formally do exam review. I am going to be there for any questions and any questions you guys will have. So I'm not going to have stuff to go over. So if you have anything to review, great. If you want to ask questions, great. If not, and you don't want to be there, it's up to you. Fill out your course evaluation. Do it now. All right, let's look at the exam test, the exam code. Yes, I stole this from another school exam or another school's assignment because I liked it a lot. It's straightforward, easy to understand, but it covers almost everything we've talked about. So the idea is we're going to implement a bunch of classes following a inheritance hierarchy. We will be making an account class and then 3 subclasses: checking, savings, and credit card. Part of the assumption, I think, is that you understand the differences between a checking account, a savings account, and a credit card account. The account will be a base class. It'll be the parent class to checking, savings, and credit cards. It's pretty explicit on what to do. You'll have these 3 variables. You will have 2 protected variables. And then you will have these methods: public. Checking will derive from account. It'll have a variable. I'm not going to read details on this. You guys can read it in detail when you get to work on it. It'll have 3 functions, or a function, a constructor, and a display function. Savings, same thing. Withdrawal function, a constructor, a display function. Credit card, private variables. Charge, payment, constructor, display function. And then a main function. This is why we went over console applications tonight. Write a main function that creates the 3 objects, starts each object with a $100 balance, and create a loop that displays the following menu. Each time through the loop, make sure the balance is updated each time and you use the objects to perform the transactions. Meaning, all the transaction code has to be in your classes. So this is what your function will look like, or your menu will look like. It'll start by printing out your balances and then offer the following menu items. The first 2 are for your savings object. The next two are for your checking object. The next two are your credit card object. The next three are your display functions. And the last one is exit. Any questions on that? It feels appropriate for 2 weeks.
Yeah, I think that's good.
Don't procrastinate. How many charges are the accounts storing? The checking account stores the last 10 checks. Credit card stores the last 10 charges. And really the names of the charge. And I think that's it.
Cool.
Good question. So as an exercise, try to visualize what your code structure is going to look like. Where are you going to have virtual functions? Maybe. Where are you going to have constructors calling parent constructors? How are you going to store things in your array? If you're storing your last 10 transactions, what do you do with your 11th transaction, your 12th transaction? How do you store the latest 12? Or sorry, the latest 10? Drop in the oldest 2, keep in the newest 10. Anyone panicking yet?
Not yet.
And want to admit it?
I have kind of a general question.
Okay.
The idea of a getter and setter is that you would have like a private variable and then public accessors, right?
Yes. Yep.
Never understood why not just have a public variable.
So let's say we were doing a, in this case, it's a great question. So we are modeling a checking account. And when I make a deposit into a checking account, are there any rules you need to apply to that number? Can I deposit a positive number?
Yeah.
Yeah.
Can I deposit a negative number?
No.
Okay. So when you have a function that is doing the logic of setting something, you can apply rules like that. So in your setter function primarily, in your setting function, you can say if it is a negative number for a deposit, reject it, like throw an error or something. If you just have a public variable, you don't have any way of having that business logic, if you will.
Or at least you would have to do it every time you set the. So I understand.
Yeah, but if you are building a class or a set of code for someone else to use, don't trust them. You can't trust them.
Okay.
Like say you were working for Acme Bank Co. and your job was to manage the health and the data within the core banking system. Are you going to trust an intern in a web application to always do the right thing?
If it's me, yeah.
Let's say it was me when I was an intern.
Okay, then
I wouldn't have trusted me. I was dumb then. I'm still probably dumb now too. So yeah, so that's the general reason why I use a getter and setter, or really a setter. But if you have a private variable, you have to have a getter as well.
Right.
So that's just a standard pattern. Really good question though.
I also had kind of a more like personal question about my, or like something I envisioned for my project. If I guess I could wait until after class though.
Okay.
Probably.
Yep.
Okay.
I'm still recording, so remember that. But I can stop recording if there's other stuff y'all want to talk about.
I mean, it's not like private. I just don't want to take time away from everybody else.
I hear you. Yeah, we'll give another minute of uncomfortable silence to see if anybody has questions. This has good advice. Build your classes first. I didn't provide a simple main method. I should have deleted that, but I am perfectly comfortable with silence as well. I have facilitated many groups in my life, and silence gets people thinking sometimes. All right. Well, let's call that